In this video, I explain the concept of multicollinearity with its definition, multicollinearity in daily life and important points. So now let's start. The term multicollinearity introduced by Ragnar Fresh. The departure of orthogonality. What is orthogonality? First we discuss what is orthogonality. In mathematics, if two vectors are perpendicular to each other, suppose that one is x and other is y. If they are perpendicular to each other, this is called they are orthogonal to each other. But in statistics, two vectors, if we represented these two vectors by in circle shape, this is x and this is y. These are two vectors x and y, and there is some data in x and in y. These two vectors are orthogonal to each other because there is no correlation among these two variables. Remember that if two variables have no correlation or no point in common, then these two variables are called orthogonal in statistics sense. So the departure of orthogonality in the set of regressors is the measure of multicollinearity. Suppose we have a model, y is the dependent variable, alpha is the intercept plus beta 1, x1, beta 1 is slope, x1 is the first regressor, beta 2, x2 is the second regressor plus error term. So these are the regressors. We also called it as independent variables or predictors. And this is the dependent variable, response variable, predictant. These are the other names of dependent variable. So the departure of orthogonality, x1, and we call it as x2. So these are orthogonal to each other because there is no point common. Suppose there is something common between x1 and x2. It means they are not orthogonal to each other. So here is the definition: the existence of perfect or exact linear relationship among some or all explanatory variables. These variables are called explanatory, regressor or independent variables. These are the same name of independent variables. If there is exact linear relationship in a regression model, then this is called multicollinearity. This is a definition of multicollinearity. Now we discuss multicollinearity in daily life. As we read previously, a situation where two or more variables are closely related, making it difficult to isolate their individual effect on the outcome. If there is collinearity and this is the outcome dependent variable, these two variables have combined effect on the outcome variable or dependent variable, then this is the problem of multicollinearity. We cannot isolate or separate their individual effects. If we want how x1 effect on the on x2 or how on y, or how y variable have effect to the estimate of the dependent variable y, then it is in the presence of multicollinearity very difficult to check their separate effects. So in daily life, suppose one variable is temperature and the other variable is temperature and other variable is sunshine or. So what is the scenario? What is the experiment? Ice cream sale. Ice cream sale is the dependent variable. Ice cream sale in this model like y is the ice cream sale, y is the ice cream sale, which is the dependent variable, and temperature is the x1 variable, and sunshine is the x2 variable. And this is the model y is equal to alpha plus beta 1, x1 plus beta 2, x2 plus error term for two independent variables. So ice cream sale are influenced by the temperature and the number of sunshine hours. However, temperature and sunshine are highly correlated, because the hours which have high temperature is due to because of sunshine. So there is strong correlation between these two variables. So if you want to model their effect on ice cream sale, multicollinearity make it hard to determine which factor is more influential. Temperature is most influential or sunshine hour is the most influential, because these two variables are collinear to each other. Some important points to be noted for multicollinearity. Multicollinearity is not a problem of method. Multicollinearity is the problem of data, because your data is collinear, and when you provide this data to any model, there is the problem of multicollinearity. So remember that multicollinearity is the problem of data. Multicollinearity is not problem of population. Multicollinearity is not problem of population. It is the problem of sample, because from one population you draw a lot of samples, and x1, x2, x3, x4, and there is chance these samples have because these samples are drawn from same population, so there is chance that there is some type of collinearity among these samples. So this is the problem of sample. Multicollinearity is not a question of degree or what kind, because when you check the relationship, there is two type of relationship: positive linear relationship or negative linear relationship. So in multicollinearity, our task is not to determine which type of relationship exists. We only determine, because positive and negative relationship both have negative impact on the dependent variable. So we only check either the relationship exists. If relationship exists, this is the case of multicollinearity, and we want to handle this issue. Multicollinearity is based on linear function. Multicollinearity is the issue of linear model. It is not the issue of non-linear relationship, like I write here model y is equal to alpha plus beta 1 x1 square plus beta 2 x4 plus error term. So this is the non-linear relationship. So multicollinearity is the problem of only linear function. If you like video, then click on like button and subscribe my channel Statistician Club to watch new videos on regression analysis. Thanks for watching.